Hey, it's Tim, Pickup Truck Plus SUV Talk. If this is your first time on the channel, welcome. On this channel, you'll find truck and SUV news, reviews, and interesting stories like this one. Make sure you hit subscribe, click the bell, and smash the like button. We're talking trucks, and trucks are awesome. So stick around, share my passion. This is a very interesting video, and I'm very excited to share it with you. I was able to interview John Catterall with the American Iron and Steel Institute. They are the voice of the North American steel industry in the public policy arena and advances the case for steel in the marketplace as a preferred material of choice. They play a lead role in the development and application of new steels and steel-making technology, and their membership is comprised of integrated and electric furnace steel makers and associate members who are suppliers to or customers of the steel industry. Basically, they're all about steel, and in this case, talking truck frames, which are all steel anyways. What I was really interested in talking with him about is newer truck frames versus older truck frames, what's going on in these frames, are holes in frames bad, and how they get around it. He has a lot of engineering experience, and he has a lot of experience with General Motors, but he also has worked with FCA and Ford and different as part of the American Iron and Steel Institute, so he has some understanding of those truck frames as well. It's a very interesting conversation, and I think you'll enjoy it. So I'm going to stop rambling. Let's go ahead and get to the video right now. All right, joining me today is John Catterall. He is the Vice President of Automotive Program for the American Iron and Steel Institute. What's interesting about this institute is he's responsible for leadership of the Automotive Applications Council. This is a group of member steel producers that they coordinate with the steel companies with different auto steel partnerships. This partnership includes representatives from FCA, Ford, and General Motors and other steel-related consortiums. So you basically work with all of them, and you get input from different engineers. And you have 4 decades of automotive engineering. You did 16 years with GM, where you led the global innovation team developing solutions for all body systems. Basically, this guy knows frames. There's a lot of information on frames. Right. And for those that are not aware, I'm going to link some videos above. See, I'm going to right up there to some situations we have with it, the Jeep Gladiator and Chevrolet Silverado ZR2. We have some bending frames, and one of the key questions on these bending frames, it deals with the frame. So if I've gotten probably 4,000 comments now on the different videos, maybe even 5,000 comments on different videos. We're talking about different frames and things. And we're talking about off the air, but you have experience, especially with the General Motors frame, the Colorado frame.
Correct. So the Colorado frame, so this is a Colorado frame, which is the mid-size, what we call the mid-size truck.
Right.
Now, are these, I forgot to ask you this prior, are these the latest model or are the older ones?
They are the latest models.
The latest models, yeah. So yeah, that was engineered here. So the previous models, that frame was actually engineered by Isuzu, and we kind of took it over. But the new models was a GM design frame, correct?
Right.
Yeah.
And so the reason I have you on is because you have a lot of experience with frames, and you, with the Steel Institute, you understand some steel questions as well.
Yeah.
Right. Okay. So and just for anybody who's going to leave a comment on this, you do not currently work for any of the OEM companies.
I don't work directly for them. However, I work with them in collaboration. So my organizations through the steel, it's really the steel companies working with the car companies to help implement a lot of the new high-strength steels, creative designs, innovations. So that's what I do. So as I think we said previously, I've got to be a little careful what I say. I'll tell it straight. So I won't do hearsay or anything like that. I'll tell you my experience from when I was engineering these frames myself.
Right.
Okay.
Right. So that makes total sense. All right. So I have some main questions I kind of want to dig into. Then we'll dig in some more questions as well. We'll get into all the stuff. So if you are really interested in truck frames and really interested in trucks, you want to just go ahead and pop a top, sit back, relax. It's gonna be an interesting conversation. Trust me, it's gonna be awesome. So let's talk first of all. There's a lot of conversations right now about high-strength steel versus conventional steel in truck frames. The conversation I'm hearing a lot is that the older frames, like the older Chevy Blazers, the older half-tons, whatever, were just thicker steel frames, thicker steel fully boxed frames, and that these new frames are so thin, they're just weak. They're just, I mean, clearly if you go thinner metal, you're weak. That's what the comment I'm getting. But I'm sensing your body language saying, wait a minute here.
No. Yeah, that's not necessarily the case because those previous frames were thicker because the material wasn't as strong. So you basically had to have a thicker section. Now with the steels getting stronger for crash reasons, we needed the stronger steel to absorb more crash energy because, like these new trucks have got to meet this frontal shallow offset right now. That puts a lot of force and load on the frame, so we needed the higher strength material. Also, that we've been trying to lightweight a lot of the trucks and the vehicles to get better fuel economy. So what it does as you go thinner, it presents a more of a challenge to the engineer, but we compensate by designing the joints better, introducing what's called bulkheads. So you basically stabilize the section with bulkheads. So actually, and then, they use a lot of computer simulation now to check the stiffness and strength of these frames. And actually, the stiffness and the strength of the frames are greater than what they used to be. So it's a misconception that the thinner material leads to a weaker frame. It does mean that the engineer has to spend a lot more time designing much better joints, stabilizing the sections, so that they actually end up they're actually stronger and stiffer than what they used to be when you do the analysis. So and that's the trick even when we do car bodies. The material is getting thinner, but you have to do much better design job and optimization to make sure they're equal to, or in most cases, better than the previous frames.
Interesting.
So this relationship between thick frame versus, strength and stiffness is not necessarily the case. So you can go thinner and actually still be stiffer and stronger. Okay. I know it breaks a paradigm, but it's a fact. And if your viewers were to take the frames and strip it down to a frame, like twist it, grab the two bumpers and twist it, see how far it deflected, and then did the same with compared the old frames to the new frames, they probably find that the new frames actually twist less than the old ones. And it's also this because people want trucks to ride and drive better, right? Mm-hmm. Some people do want them to be more like ride like cars. I don't think maybe a lot of your viewers are not as interested in that, but there's been this drive of refinement of these trucks too, that they want them to feel great when they drive around down the freeway as well. You get a lot of that by having a stiffer frame.
Interesting.
So this move to high strength steel doesn't necessarily mean they've got weaker when the material gets thin.
And just for clarifying stuff, high strength steel, is that just a different alloy composition of steel?
Yeah, that's how you do it. It's a different chemical composition. Also, it gets some of its strength through post heat treating as well. Okay. So, a lot of the steels that we used in the frames, 20, 30 years ago, it's what we call 30 KSI. And I'm going to use KSI because I think a lot of the industry still does. And now we've got materials that are all the way up to 90 KSI, so they're 3 times stronger. Now, if you basically, then you technically could say, I only need 1/3 the material I had and go divide by 3, and you get that much thinner. However, it doesn't work that way because you then get instability problems.
Okay.
So it's not a direct correlation because we've needed that extra strength for these new crash requirements and extra towing capacity. And everybody's trying to increase their payloads, increase their towing capacities. So we've utilized that higher strength steel, down gauge to get some weight savings, but also we've improved the performance in most cases. So,
interesting.
And that's the challenge of an engineer. The chief engineer always wants lighter, stiffer, stronger, cheaper. Basically, so it's an easy task, right?
Right.
We've always got to make it better. We've always got to make it lighter, and we've always got to make it more cost effective. Easy job, right? That's why I'm bald. I've lost my hair worrying about all that. Right?
All right. So this other question I'm hearing, and I may have got this wrong. I'm always a humble guy. I may have gotten this wrong. I've talked to different engineers about this. But do holes in a truck frame make the steel weaker, the steel frame? And for those to understand, and maybe you can explain more of this, is that truck frames have holes in them for a variety of reasons. I've heard conveyance through the factory, flipping them for e-coating, inspection sites for welding, getting tools in there. I mean, that's a very common thing.
Yeah. So I was going to bring up some of those requirements, like the e-coating. You've got to get that e-coat on the inside. You've also got to get the electrical current. Believe it or not, the holes allow the electrical current to deposit the coating on the inside as well.
Okay.
And they do simulations for all that. What you can do if you do put a hole, that maybe is in a sensitive area, you can put a flange around it or a depression around it, like a racetrack, right, that recovers for the loss of maybe some stiffness in that area. Now, engineers now, like I said, with all the simulation they can do, you've got in a frame like what you call hot spots and cold spots. You've got an area of the frame that's really working, so you'll call that a hot spot. Don't put a hole there, right?
Okay.
You'll have these cool areas where you'll look at all these stiffness tests and crash tests, and you will always look for the area where the material really is almost along for the ride and is not doing much in that area. That's where you want to place your holes. You do get that situation where to get a good E-coat coverage, you might have to put a hole in an area that you really don't want to, but you want the E-coat coverage because you want good corrosion performance, right?
Mm-hmm.
So there's a lot of science put into where those holes go. Now, those holes lead to a lighter weight frame, which is good for fuel economy and handling performance or whatever as well sometimes. So, trust me, no engineer puts a bad hole in. Now, do they make mistakes from time to time? Maybe, right? And then they have to recover and maybe they'll do a running change to modify that hole. Usually, but there's ways to compensate for the loss of stiffness when you put a hole in, like the flanging and things. So that's what we do.
Right.
Yep.
So it's incorrect to say. So I want to make sure I get this correctly. So we have a truck frame. As you add holes in, it does make the frame a little bit weaker, but then you compensate by that with flanges and stuff that make the frame the same stiffness.
Bingo. Yes.
Okay.
So we recover it, and bulkheading might be a way to do that, or we do a thing called through. Like a through tube as well, that will help stabilize that to make sure that you're not stressing that area that's got the hole in it.
Okay.
Yep.
All right. The third question I keep seeing a lot, and nature of the beast these days, is the steel. You hear a lot about U.S. steel, and steel as an industry has been ups and downs, things that's changing. And the comment I'm seeing a lot is that the steel used in truck frames is Chinese steel. There's this whole thought that Chinese steel.
Yeah, that's actually not correct. So most of the steel used in frames produced here in North America, and that includes Mexico and Canada, by the way, because they build a lot of frames in Canada, and they also build a lot, as you know, down in Mexico. GM has a big frame plant down there as well, and I visited that frame plant, one that Magna owns. Actually, Magna owns the one up in Canada as well. They source that steel locally because you don't want to be shipping. Truck frames have a lot of steel in them,
sure,
right? You don't want to be shipping that from another continent. Ideally, you would ship it from next door, right? There's cost involved in shipping coils of steel around the world and even around the country. So you actually, just from a pure business standpoint, you want your materials and your components to be as close to your plant as possible to cut down on the cost of shipping that material around. Because everybody's so cost sensitive, you want to be able to make the best profit you can, right? Mm-hmm. There's also another reason for sourcing the steel locally is that the steel companies help with what they call application engineering. So if, say, Magna, who makes some of the frames, is stamping out a side frame member and they end up having some issues with the steel or the part's not forming the way they want, the steel companies will actually go in and help them resolve the issue. So you actually want the application engineers from the steel companies to be close to the point of production as well. And you want the supply chain to be as short as possible from your factory to where they're making the steel. So I can't quote numbers, but when I was at General Motors, I don't remember any steel coming in from abroad to be able to make the frames. As far as I knew, Magna was sourcing all the steel locally. Yeah. So the stories of the demise of the U.S. steel industry are just not true.
There you go. I was going to ask about current steel frames from older frames, but I think we answered that.
Yeah.
I did want, let's see, we just talked about the steel marketing industry being high or low or what's going on there. But let's dig in this a little bit more. So that was my question. But I want to dig a little bit more. In the frame construction, I just remembered some other questions that come up. There was some conversation about why don't truck makers use big C-channel frames like medium-duty trucks has, like 450s and 550s, in smaller trucks if that C channel is stronger. Do you have any statement on whether a C channel is stronger than a box frame, if a box frame's stronger than a C channel?
Your box frame is always going to be stronger than your C channel.
Okay.
Because a C channel, is going to have more, it's going to twist a lot more, right? Once you box off, this is now a box that isn't going to twist as much. Now, the reason you see, when you get to a very deep C section, right, that you can make really thick because it's that heavier, almost commercial-like truck, right? Mm-hmm. Now it's very stable because it is so thick, right? Putting this extra material on the side, you may actually be doing yourself a disservice from a mass standpoint. So if you've got a very deep, thick C section, that might indeed be more mass efficient than then going boxing that off. But certainly when you get to the smaller, let's call them the full-size truck, like the Ram truck and the Silverado, and the Ford F-150, they're getting more package constraint as well. And then the box is always going to be more mass efficient. Now you can actually put some lightning holes in the middle of the box to take some mass out, because any material on what we call the neutral axis, I don't know if you know, when you're bending something, it's the material on the top and bottom that's really doing the majority of the work, and the material on the side is like stabilizing everything. The material right down the middle is not doing as much work. So you can then maybe lightweight a box. But boxes will always be stiffer for the overall performance of the vehicle.
Interesting.
So you'll notice when anybody's touting stiffness of their frame, they always mention, we've gone to a fully boxed frame. You'll hear that. You'll hear Ford saying that. You'll hear Ram saying that, and Chevy. Because way back, a lot of the midsections were C-sections. If you go back in history, you'll see that. They boxed them off and it's some of that going thinner too, that they had to do that, Tim, because, you've now got that weak. Once you get too thin on a weak section, it becomes very flimsy, and then you have to box it. So that going thinner has led to a lot of the boxing off of the frames as well.
And that brings up an interesting point. Let me ask you this. Since you work with members such as Ram and Ford and General Motors, is frame technology so different between the different truck manufacturers? Is everybody doing something wildly different, or is it kind of a frame's a frame?
They're kind of going in a very similar direction. They're going to the higher strength steels. As you've seen, some of that is crash and things like that. They're going more, like we said, fully boxed along the full entire length now. Now you got to remember, they have frame suppliers, right? So they are pretty much going to the same frame suppliers that build the frames. I don't think any of the OEMs build their own frames. It's basically a tier one supplier, like a Magna, like a Metalsa. You've probably heard some of the names: Magna, Metalsa, Tower was one of the old ones in the past. Dana and A.O. Smith were the really old ones. So it's really the tier one frame suppliers that are actually innovating. And of course, they prefer to, if they're building for more than one OEM, they prefer to build them very similar for each OEM, right? Sure. So, and you probably saw some of the trends in the past. There was hydrofoam sections on front and rear of frames. They seem to be moving away from that and going more back to the clamshell, the box sections. Hydroforming does have some restrictions with it over the length of a tube. So they're all pretty much going in a similar way. A lot of bulkheading, a lot of boxing, thinner, higher strength, because it's what the OEMs are asking for and need to get the performance they're looking for. So I'm a bit jaded because I've been doing this so long. At a high level, I think they all look the same. Right. But if you dig in, there's little nuances here and there where they do things a little bit different. And if you want to get very geeky about it, you can see those differences. But at a high level, they're all very similar, and you probably see the same thing.
Yeah, one of the questions that came up a lot in the comments of these videos was the fact that it was such and such company made a cheap frame, or this person made a cheap frame, or if they just would have buy a Toyota frames don't bend like that, or whatever. But as I've described these accidents to you, it seems like all the frames would be the same kind of frames in a similar type of situation where excess speed, mass added to it from a trailer. It seems like everything would bend.
One thing that might be different between various OEMs is the test cases they're using to design and engineer the frame and or the vehicle. It's not unusual for one of them to maybe miss one, right?
Okay.
Or something special comes along. There's always, as you know, they design for what you call the 95th percentile or the 99.1 percentile. The biggest challenge for every engineer is that 0.1 percentile, right? Mm-hmm. That gets missed. And it's a lot of times leads to maybe an OEM introducing a new load case into their design and development cycle to take care of that one or two instances that happened out there. And I've been party to that. When I was at General Motors, new requirements would come along because of something they found out in the field, and the next time they go to redo that frame of that vehicle, you'll have an additional requirement put on the vehicle because something popped up that, engineers are not perfect, and sometimes they miss this unusual case that comes along, and they adjust and engineer for it later. So it's very rare that they find a significant issue where they've got to go back and retrofit a whole bunch of frames of vehicles. It's down to the one-offs, which is pretty impressive when you think about it.
Right.
There's 20 million ways to abuse or break or damage a vehicle or a frame, right? Uh-huh. And I'm very confident that the customer base will find a way to do it, right?
Yeah, definitely the hold my beer, watch this moment. But let's talk about these frames as well. From a repair standpoint, when these frames get bent, can they bend them back and still be structurally sound?
That's getting more and more difficult. One of the things with the high-strength steels, if you apply heat to them, which was an old method, or you might apply a little bit of heat and then pull back the frame, right? Because you need to do something to make it yield, because if it's in a bent shape, you've got to do something to be able to bend it back, which is either overbend it or maybe apply a little heat to soften it so you can bend it back. It's getting a lot more difficult to bend them back, number one, because this material is so strong, it doesn't want to bend back. Also, you can't apply heat to them anymore because it actually changes the microstructure of the steel, and it can weaken it to a point where you don't want to be driving that truck around once you've applied heat to it. Oh, really? So the OEMs do put a lot of advice out there to the repairability world, and it's something that we work on as an organization as well. How do you repair these vehicles when they're damaged or bent? It's getting more and more difficult to bend them back, which unfortunately might lead to somebody saying, I've got to go buy a new frame. Yeah. Which is a big deal, right?
So basically in both these cases, these trucks with the bent frames, you're almost looking at totaling out the vehicle because the cost of frame and swapping them would be at such a price.
Now, without looking at the detail, it all depends where the damage is. They do come up with some sectioning recommendations, okay, where you can perhaps cut the frame at a certain place, MIG weld back on, a new portion, and essentially over repair that area, and it might even be stronger than the previous frame. So they do allow some sectioning, but it's always good to go look at the suggested repair procedures from OEMs. They tend to put them up online, or the dealers might give you a hint or tell you there are recommendations about how to repair certain things on frames, so you don't have to, because the insurance industry doesn't want to be basically totaling frames out or cars out. Right. They want to be able to repair if they can. Every time we've gone to talk to a repair company, their preference is to repair the vehicle and obviously not write it off, because that's a huge deal at that point.
Right.
And by the way, the engineers, there are repairability engineers at the OEMs that are working on that daily, because they don't want a particular vehicle to get a bad reputation that it's difficult to repair.
Yeah, so I mean, the amount of views these videos have gotten, I'm pretty sure Chevy and Jeep have watched these videos many times, and I'm sure that they're looking for these trucks right now to look at them and inspect them.
Well, and I hope they've sent engineers to go look at these trucks and find out root cause what went wrong. Like you and I were talking about earlier, was there something done in a retrofit that maybe somebody did put a hole where it shouldn't go? It is amazing how sometimes a hole put in the wrong place, and it can be even a relatively small hole, can have a devastating effect. So you've just got to be careful. These are finely tuned designs now, because of the challenges of crash and stiffness and strength and weight, that they're having to squeeze out all the inefficiency that they can. Right. So caution, don't drill too many holes in your frames.
Well, another thing I was talking with about and doing was that caution on adding much steel to your frames, because when you add more steel and weld it, you actually burn off the E-coating.
Well, which can affect your corrosion. Also, it changes the stiffness balance along the frame, because if you overstiffen one area, it could push some additional loads and stress into another area and have a detrimental effect.
Yeah, it's interesting.
Right.
The Australians have been commenting on this story because they see utes all the time with bent frames in the Outback because they don't have a full-size truck. They don't have a heavy-duty whatever. They take their ute out and they just haul whatever they have to because that's the only choice they have. And I was looking online, and they actually have retrofit kits for Australian ute pickups that are pieces of steel that you weld to the back portion of your steel frame. These kits still have holes in them. The frames still got holes in them, but you weld too. And I'm thinking, boy, you add that additional mass back there. It sounds good maybe on paper, but I don't know about crash safety and about like how the tuning of the truck would work.
Oh, yeah, it would. I mean, doing that sort of thing really will affect your crash safety, right? Because as you know now, a lot of frames or even, parts of car bodies, they're designed to crush to absorb the energy. Mm-hmm. If you get that was one of the problems with the early body-on-frame cars. The frames were so stiff and strong, you'd hit that frame and no energy absorption, and it was very bad for the occupant. They would go into the steering wheel, into the IP. You want to absorb energy. So, and OEMs will do this and say this. As soon as you start modifying your vehicle, they're basically not going to take any liability after that, right? Because you are basically changing the way it was designed to perform, and you're running risk. Okay, so that's you've got to be careful when you start modifying vehicles, for sure.
Very interesting stuff. Well, hey, thanks for joining me today.
Oh, no problem. I appreciated it. I'm sat at home not doing much right now anyway, right?
Right.
That was a little joke because I spend more time on the phone now than when I was at work. But yeah, I appreciate it. Good chatting with you.
Well, there you go. I hope you enjoyed the conversation. I thought it was very interesting, and I learned quite a few new things. So go ahead and comment below. What did you think? Did you like it? Did you hate it? Do you have follow-up questions? Let me know, and I'll see what I can do to get those questions answered. So remember, for more Pickup Truck Plus SUV news, find us on pickuptrucktalk.com. Those 3 words work again on Facebook, Twitter, and Instagram. Just type it in. Trust me, we're there. I've done it. That's always a good time. We have memes and different videos, and just have a good time over there. You should come check it out. As always, thanks for watching. I'll see you down the road.